Hello everyone, so this is Corbin Moss and I will be going over the exercise 5. So the first thing that we were looking at is the shortcomings of hierarchical clustering, and there's going to be 3 main points. As 1, it cannot contain a large number of clusters. 2, does not work well with mixed data sets. And finally, the third shortcoming is does not do well with large data sets. And the next thing we're going to look at is the perch. As we can see, consumers data points 1 point at a time and incrementally builds hierarchical clustering. And if data that is entered is similar to any relevant neighborhood in the dataset, it will apply rotations. It is used to scale to a large number of datasets and a large number of clusters, and it uses A* to find the nearest neighbor search system to characterize the datasets. Now moving on to the k-means clustering, as we'll look at shortcomings for this. But right now, what is k-means clustering? It is used to cluster data together. And when clustering the data with k-means, we are asked to identify how many clusters we would like to identify. And after doing this, we are asked to randomly pick 3 data points. These are our cluster points and measure the distance between the first data point to the selected cluster points. The data points then are assigned to whichever cluster point is closest to them. And when new data is inserted, the new data will be measured and placed in the correct cluster based on its characteristics. So the 2 biggest shortcomings of the k-means clustering is determining how many clusters you need, due to this being us figuring out how many we need, so we're not particularly sure, and outliers may be added to the wrong clusters. So moving on to the SAS-VIA part of the exercise. We were asked to pick basic stats from the NBA 2018 dataset. So as we can see, I picked steals, rebounds, points, minutes. And going into the cluster, we can see the variables that I picked. And then going to options, we can see that the general cluster count is at 5. And then for the second one, we were asked to do 7 general cluster groups. And for page 3, we can see that we were asked to do 9. And then second, we were asked to change the number of bins from 16 to 10 and 4. So coming back here, we're going to change the number of bins to 16. So as we can see, this is how it changes the data. 10 and then 4. So 10 looks like it's going to give us the greatest amount of information and the best overall look at how each player does. And as we can see, that the higher the spectrum, that this gives us our elite players, our starters, and our bench players.